The other type of compression, continuing on from our discussion from the last movie, is temporal compression. Temporal meaning time. And so, as we talked about, spatial compression will look at a frame and then compress that frame. Well, temporal compression will look at a series of frames and see what's different. So, it might look at this current frame, and then as I go to the next frame, it looks almost identical. And the next frame's almost identical, next frame's almost identical, next frame's almost identical. So it can look at all the pixels that are the same. And the temporal compression method will look and say, well, if this pixel is the same through the next 10 frames, then I'll just remember that pixel and I won't have to make 10 different copies of it. I'll just remember that it's basically the same. In other words, it doesn't have to keep track of every single pixel. It just has to keep track of the changes over time. Now, this is a very simplified way of explaining how it works, but that's the basic idea. So spatial compression is again referred to as intra-frame compression, and temporal compression is referred to as I-N-T-E-R, interframe compression. And as spatial compression is to image compression, then temporal compression is to motion compression. So it looks at, again, a series of frames over time. And as with spatial compression, the more you have action, the more movement you have, then also the more changes you have from frame to frame, and the more that temporal compression is not going to be able to compress things quite as much because there's all kinds of new information on so many pixels from frame to frame. Now, not too many formats use temporal compression, and I'll tell you why. The ability to use temporal compression really makes small file sizes because you're not only compressing spatially, but you're compressing in time as well, and it really brings file sizes down quite a bit. The problem is that these formats have to use something called a group of pictures. It has to group, say, like 20 frames, and then look at all of those frames and keep those frames together in a whole. And then editing them is kind of a nightmare. It's much more taxing on your system. So say, for example, let's go to the sequence dropdown so we have some visuals here. I'm going to create a new sequence, and we get in this new sequence dialog box, and we see a couple of the big interframe compression methods. HDV is a big one. MPEG-2 is a big one. AVCHD is a big one. These are great formats. They're very optimal compression, but they're very hard to work with when you're editing. And again, it does take a lot more out of your system to process those files as you're working. It has to kind of unwrap them in a very complex way that slows things down quite a bit. Now, one of the new formats that's making a big stir is AVC Intra. You see, AVC HD is a pretty powerful compression method, but it is an interframe, or in other words, temporal compression method. And so what they've done is they've come out with AVC Intra. So it uses a lot of the genius of the AVC compression method, but it's an intra-frame, or in other words, spatial compression type. So basically, it's all the benefits of AVC HD and all the benefits also of spatial compression, which you don't have in AVC HD. So it's my prediction that we're going to see a lot more AVC Intra in like handheld video and other things because it's a really optimal format, easy to edit with because it has spatial compression, and yet it does a good job of compressing stuff as well. So there's a little primer on video compression. Hope that helps. To sum up again, AVC HD, HDV, MPEG-2, those are temporal compression algorithms and often called interframe compression. So they do compress things quite a bit, a lot of quality, very small file sizes, but they're kind of a mother to work with when you are editing. It's often better to use a spatial compression method for the files that you are editing, such as AVC Intra or most other file formats.